Hello, my dear students. We'll take one more example, how to find shear force values and bending moment values and to draw shear force and bending moment diagram. Okay, a simply supported beam AB 6 meter long is loaded as shown in figure. Construct the shear force and bending moment diagram for the beam and find the position and value of maximum bending moment. Okay, this is the beam given AB of length 6 meter. Okay, and here one UDL of 4 kilonewton per meter and one more UDL 2 kilonewton per meter of 3 meter length and one point load 5 kilonewton. First, what we have to do, we have to find the reactions RA and RB. How we can calculate? Take vertical forces equal to 0. So what is that? Upward force is positive, downward force is negative. So here RA, this is plus RA, and this is plus RA. Here reaction developed is RA and plus, and then this is RB plus RB upward direction and minus 4 into 1.5 because UDL you have to multiply by this distance. 4 into 1.5 minus 2 into 3, this UDL is of 3 meter length, minus 5 equal to 0. Okay, next write in terms of RA what you will get. 4 into 1.5, it goes after right side, so sign changes. So 4 into 1.5 plus 2 into 3 plus 5 minus RB. Okay, let it be the equation 1. Next, consider moment about A and equating the same. What happens? The moment summation of moment is equal to 0. I'll take about A. So what is that? Minus RB into 6 because this RB clockwise is positive and anti-clockwise is minus. Okay. So this is direction moving in this direction. So force into perpendicular distance. So RB into full distance, that is 6 minus that is minus anti-clockwise. Next is this 5. What is this direction? It has to move like this, so that is clockwise. 5 into this distance. What is that distance? 5 into total is 6. 6 minus 1.5, that is 4.5. So okay, so it is 5 into 4.5. Next, this UDL is 2 kilonewton per meter. 2 into 3. First you have to convert into load. How? Force into perpendicular distance. So 2 into 3 into, you have to take about A. So half of the distance 3, that is again 1.5. 1.5 plus this distance. What is that? 1.5 plus 1.5 plus 1.5. So it becomes totally 4.5. Okay. So 2 into 3 into half of this 1.5 plus this is also 1.5. okay, total is 6 meters, so this is also 1.5. so this is 2 into 3 into 1.5 into 1.5 plus 1.5 plus 1.5, so that becomes 4.5 plus one more load, that is 4 into 1.5 into half of 1.5, that is 0.75 equal to 0. So write in terms of RB is equal to total, calculate this, you get RB is equal to 9 kilonewton. Once if you get RB, substitute in this equation 1, so you get RA is equal to 8 kilonewton. So this is the first step. After that we'll calculate how to find the shear force. Okay, so I have told now right side upward is negative and right side downward is positive. Okay, remember that. We'll find at different points. So first one at shear force at B, that is nothing but shear force at B is RB, that is minus RB, right? Because right side upward, this is right side, I am considering from the right side upward is negative. So minus 9 kilo Newton RB. Okay, next shear force right to E. Okay, this point. What is that? Minus RB plus this is UDL 2 into 1.5. Okay, why plus? Because this is acting in the downward direction. So UDL it is. So you have to multiply by distance. So shear force at right to E is minus RB plus 2 into 1.5. Okay, you get minus 6. Next, shear force at E. What is that? Till here it is minus 6 plus 5. Okay, right side downward plus, that is equal to minus 1. Next, shear force right to D. What is that? Till here it is minus 1 plus 2 into this distance. Now only this distance we have considered, because already I have considered till E that value, that is minus 1. So minus 1 plus 2 into this distance. What is that? 1.5. Right? Total is 3. This is 1.5. So this is also equal to 1.5. Okay. So that is equal to 2. Next, shear force at D. Here there is no load, nothing. So whatever it is left right to D, that is equal to shear force at D. That is equal to 2 kilonewton. Next, shear force right to C. Here also there is no loading. So that is equal to 2 kilonewton. So shear force at C also there is no load, is equal to 2 kilonewton. Next, shear force right to E. What is that? 2 till here it is 2. 2 plus, why plus? I have considered from the right side downward is plus, so 4 into 1.5. So 2 plus 4 into 1.5, that is equal to 8 kilonewton. So shear force at A is equal to, that is also equal to 8 kilonewton. Okay, like this you have to calculate shear force values. Okay, so first at B, then right to E, then at E, then right to D, then at D, then right to C, and at C, then right to A, at A. Okay, next we will calculate the bending moment. How to calculate bending moment? Let us consider this beam. Okay, bending moment at B, obviously it has to be 0. We know bending moment is always 0 at the supports. Okay, so bending moment at B is 0. Next point is at E, this point. What is that? RB into this distance. Okay, that is RB is C sign convention, all of you know now. That is okay, this is plus. Okay, this is plus and this is minus, correct? Okay, this is plus. Okay, like this direction. Okay, this is plus. Okay, this is minus. Okay, now shear force bending moment at B is 0. Then bending moment at E, what is that? RB, this is moving like this direction, RB into 1.5. Okay, minus, because this UDL is there, that is acting in the downward direction, it moves like this. Okay, that is in this direction, that is in this direction. So right side clockwise, that is minus. So minus 2 into 1.5 into half of 1.5, because now this is bending moment. So you have to calculate force into perpendicular distance. Okay, first step is 2 into 1.5, that is you converting UDL into point load. Then again you have to multiply half of the distance. Okay, so now what is RB? RB is 9. So 9 into at E, now I am calculating at E, 9 into 1.5 minus 2 into 1.5 into half of 1.5, that is 0.75, you get this value. Okay, next point at D, what is that? Now again RB into this distance 3 minus this 5 into 1.5 minus 2 into 3 into half of 3, 1.5. So you get 10.5. Next, shear force at C till here. What is that? RB, like this direction, plus RB into this distance. What is this? Total 6, here 1.5. So till here it is 4.5. So RB is 9. 9 into 4.5 minus 2 into UDL 3 into half of 3 is 1.5 plus still C we are considering. So this also distance you have to consider, that is 1.5. Okay, so that is why 2 into 3 into 1.5 plus 1.5. Okay, then shear one more, this load is there, point load 5 into this distance. What is the distance? 5 into till here, that is 1.5 plus 1.53. Okay, you get this answer. Next, shear force, a bending moment, not shear force, bending moment. Bending moment at A, obviously it has to be 0, but just check that how you will get 0. That is RB into full distance. RB is 9. 9 into 6 minus this 5. 5 into this distance, that is 4.5 minus 2 into this distance, 3 into half of 3 is 1.5 plus till here to here, that is 1.5 plus 1.53. Okay, minus 4 into this distance, 1.5 into half of that, that is 0.75. So you get this equal to 0. Okay, now you draw the diagram. How to draw? SFT is at B, we know it is 9 kilonewton minus 9 kilonewton, so below the line. Okay, then at E, or right to E, that is equal to minus 6. Okay, so it is minus 6. Then at E it is minus 1. Okay, then at right to D it is 2 kilonewton. So here UDL, so this is linear, changing sign minus to plus. Then at C also 2. Okay, right to C also 2, so it's a line constant. Then from 2 to it is increasing to 8, again here UDL, so inclined line. Okay, so this is the shear force diagram. Here minus and this is plus. Then draw the bending moment diagram at B0, at E 11.25. Then at E, this is not there. At E we are not, yeah, at E 11.5. Then at D it is 10.5. Then at C 7.5. Here whatever the values calculated, that one only substituted. At A is equal to 0. Okay, now what you have to calculate is, you have to find where is the maximum shear force, maximum bending moment lies. Where it is maximum bending moment always will occur where the shear force changes its sign. Here where shear force changes its sign, shear force changes its sign here, minus to plus, that is at M. Okay, I consider this is the shear force. Okay, at M. So let us consider this is at a distance of X from B. Okay, now I have to calculate shear force at this point, shear force at M. What is that? Shear force at M is minus 9, right side upward negative, minus 9 plus 5 plus 2 into till here. What is that distance? Here. Till here you have to consider shear force. Okay. Let us, this is still here. Okay. What is that? Minus 9 plus 5 plus 2 into, what is this distance? Till here X. Okay. 2 into X. So that's why here I have written that shear force at X. Okay. Minus 9 plus 5 plus 2 into X, so you get X is equal to 2 meter. Once if you get X, you can calculate what is bending moment here. Okay, at this point, what is that? 9 into here, this distance X, 9 into X plus minus 5 into this distance. What is that? X minus 1.5 minus 2 into X by 2. So this one. So 9 into 2 first, that is this distance, 9 into X. X is 2, that's why 2 minus 5 into 2 minus 1.5. 2 minus 1.5 minus this. Okay, so 11.5 that you will get. Like this you can calculate. Thank you.